We're recording.
Good morning.
Good morning. Welcome to Unit 3, Power and Taylor series. We're going to start with a PowerPoint that introduces you to what a power series is. You don't need to write stuff down for this. It is so much more important that you listen and think and pay attention. So I don't want you to waste time copying. I'll tell you when you need to start taking notes. But I just want to think through conceptually what it is we are doing. We're talking today about power series and their interval and radius of convergence. To start, we're going to look at geometric series. What is a geometric series? And this is what I was scared of. Okay, so that's what it converges to, but how do you know a series is geometric? Multiplied by the same thing each time. Good. So geometric series, you start somewhere. What do we call that thing you start with? What? A. And we multiply by what each time? R. And then we add them all up. So geometric series looks like A plus AR plus AR squared plus AR cubed, on and on and on. If it's infinite, it goes on for forever. We can write a general term that looks like that. On this general term, why do I not have to the n minus 1? Usually it's to the n minus 1, the ones that we, because it starts at 0. Good. So n equals 0 is where I start, my index. So it's AR to the n.
So you can have negative. Like if it's n minus 1, it'd be r to negative.
Then you start at n.
No, then I'd start at n equals 1 for it to be geometric. Does a geometric series converge?
Yeah.
Sometimes. Yeah. When does it converge?
Less than 1.
What?
When r is less than 1.
When the absolute value of r is less than 1. That's when it converges. You would plug in, you'd add up all these terms and you'd get a number, approach a number. What does it converge to if it converges? A over 1 minus r. So it converges to a over 1 minus r if the absolute value of r is less than 1. What happens if the absolute value of r is greater than or equal to 1? It diverges if r absolute value of r is greater than or equal to 1. So we already know all of that. Cool. We say that -1 to 1 is the interval of convergence. Does that make sense? It's a new word. What does interval mean?
The range?
Range of numbers that make it converge. That's what interval of convergence means. So that's some new terminology. Interval of convergence. You don't have to write it. I mean, it's intuitive, right?
Yeah.
The interval of convergence is a set of numbers for which the series converges. That's practically using the words to define themselves. But when I ask what's the interval of convergence for a geometric series, you say r has to be between -1 and 1. Radius of convergence, r, is the distance from the center of the interval of convergence to the endpoint. So for geometric series where the interval of convergence is -1 to 1, where's the center of that interval? 0. So what's the radius? How far from 0 do you go to either side?
1.
Yeah, so the radius of convergence would be 1. Does that make sense? If the interval of convergence was from -2 to 2, radius would be 2. If the interval of convergence was from -1 to 3, what would your radius be?
1.
Your center would be 1. What would your radius be? 2, because it's 2 from either side of your center.
Wait, what's your...
Radius is the distance from the center of your interval to either endpoint.
So your center is 0.
No.
You said your center...
We'll do more specific examples. That's hard to think about it looking in your head. But yeah, that's the idea of the radius of convergence. So we're going to look forward to geometric series and say, what if r was a variable instead of a constant? So it's a function of x. So instead of a r to the n, it'd be ax to the n. What would your first term be?
1. Wait.
Oh, A.
A. What's your second term?
AX.
Ax. What's your third term?
AX squared.
X squared. On and on and on forever. Is this, if I plug in 5, if I try to evaluate this function and try to find f of 5, what am I going to get?
Wait. 5 to 0.
If I plug in 5 for x, that says a times 5a plus 5a, it diverges. Does that make sense?
Yeah.
If x is 5, Then I multiply by 5 each time and add up all my terms. I plug in 5, my function is going to be undefined.
Because it's not original.
Why is it going to diverge? Keeps getting bigger and bigger. But what if I plug in 0.5 for x?
Zero for each one.
Each term gets smaller and smaller. Am I going to get a number out at the other end?
Uh-huh.
What's that number going to be?
1.
So if I plug in 0.5 and do a plus 0.5a plus 0.5 squared a, what's that going to converge to if I keep going forever and ever? Depends on what a is. What do geometric series converge to? A over 1 minus r. So it's going to converge to a over 1 minus 0.5. Let's go over that again. Do you see that this is a function? I plug in numbers and I get out whatever that infinite sum equals. If I plugged in 5, would I get a number out? No, because this function diverges when x is 5, when your r is 5. So my function would be undefined for x equals 5. Does that make sense? If I plugged in 0.5, would I get a number out? Yeah, because my function converges if x is less than 1 and 0.5 is less than 1. So I'd get a number out. I'd get a over 1 minus 0.5. So it's still input output. Does that make sense? Input 5, your function's undefined. You don't have an output. Input 0.5, you do get an output. Does that make some sense? So this series is a function of x. And that's what's important. It's a function. It has input and output. But some inputs lead to a convergent number. Some inputs diverge. So sometimes your function's defined, sometimes it's not. One step further. So what if the coefficients of each term were different? So I have f of x. And the series we just looked at was a plus ax squared. What's the coefficient on every term? A. Now we're going to let those coefficients change. So we're going to call it, instead of a, c sub n for coefficient sub n. That means my first term is c sub 0 times x to the 0, which is just c sub 0, plus first coefficient times x, plus second coefficient times x squared, plus third coefficient times x cubed. You see how this looks sort of geometric? Now it's not geometric anymore because my coefficient's changing, but it's built from this idea of a geometric series. This is a power series. Have you ever been walking down the street and someone comes up to you and stops you? Like that you don't know?
Yeah.
Yeah. So that happens to me all the time. And 9 times out of 10 people ask me, what's a power series? And I'm like, I started to need a really, really easy way to explain to these people what power series were. Because, I mean, has that ever happened to you?
Yeah.
Okay, yeah, and what have you had to say?
No.
I don't know. You haven't known, but now you can answer that question. So this is really exciting. A power series is a series where the terms are coefficients times x to a power. So a power series is made up of coefficients times x to a power. Does that make sense? What's a power series?
Coefficients times x to the power.
Some coefficient times x to a power. Good. So that's how you should explain it from now on.
Okay.
People will understand. It's very simple. It's coefficient times x to a power.
When I get asked that once, it's exactly what I said.
Good. What?
Like that.
I'm going to post this online. It's more important that you just see it right now.
All right.
So yeah, a power series is a type of geometric series where each term is obtained by multiplying by a variable or a variable phrase. A power series, we say, is centered at 0 if it looks like that one that we just had. Coefficient times x to a power. Coefficient times x to the 0 plus coefficient times x to the first plus coefficient times x to the second, and so on. And it goes on forever and ever. We say it's centered at a if it looks like this. What's the only difference? It's x minus a to the n. And you can think about this like if you think about the quadratic, y equals x squared. Where is that centered? 0. If you do x minus 4 squared, where is it centered? You move to the right 4 and now it's centered at 4. Does that make sense?
Yeah.
So that's where that x minus a sort of comes in. So then you get c sub 0 plus c sub 1 x minus a plus c sub 2 x minus a squared. So you just substitute the x's with x minus a's. What's the power series? Coefficient times x to a power. Perfect. We're gonna play a game.
That's really funny.
Silly. What? Oh. No, this game is probably my favorite game that we play in here. It's called Is This a Power Series?
I like Is This Quotient?
Oh yeah, we played Is This Quotient Rule. Do you remember that?
We did?
But now we're gonna play Is This a Power Series? Yes, we did. Okay, so
No.
is this a power series? What's a power series? Coefficient times x or x minus a to a power.
So no.
Zane's saying yes. Yes. So we need to be able to determine what our coefficient is and what our variable expression is. What's our coefficient?
1 over n.
Perfect. That's your coefficient. Does it change as n changes? Yeah. You plug in, so it changes as n changes, but it is your coefficient. You know what to put in front. And what's your variable expression? X minus 2 to the n. It's coefficient times x to a power. It doesn't have to, but it can. Yeah. With real geometric series, it doesn't change. Look at what's attached to your variable expression. Do you see it's like that coefficient times x minus 2 to the n? Where is this power series centered? At 2. So this is a power series centered at 2. Next one. Is this the power series?
No.
Yes.
No.
What?
Okay, think.
Does the whole thing contribute to the-
Thumbs up for yes. Thumbs down for no. That way YouTube doesn't know if you got it right or wrong. Yes, this is a power series.
So your variable is x to the n.
Uh-huh.
Your coefficient is 1 over 2 natural log.
Perfect. Coefficient is 1 over 2 natural log of n. And your variable expression is x to the n. It's just 1 over 2 natural log of n times x to the n. Where's this one centered?
It's
0.
At 0. Because it's just x to the n, not x minus a to the n.
okay.
Next one. Is this power series? Thumbs up, thumbs down. What's a power series?
Coefficient times x to
Coefficient times x to a power. So look and see if this is a coefficient times x to a power.
no.
This is not a power series.
No.
No in Spanish. What am I missing?
Your coefficient.
Yeah, you're X.
I have no x's.
Oh.
This is not a power series. This is just a normal, what kind of series? Geometric series. It's a normal geometric series from last unit. I do not have x to a power here. Not a power series. It's just a normal geometric series.
Oh,
Does that make sense?
X's.
Mm-hmm. There's got to be coefficient times x to a power. Is this a power series?
Oh.
So don't yell out, just think. Is it coefficients times x to a power? Zane's really good at this game. Zane, is this a power series?
What?
Do you have coefficients times x to powers? It's power series.
X squared.
It is a little harder to figure out what the coefficients are. I mean, look at what's the coefficient on the first term? What's the coefficient on the second term? Negative 1. Then it's what? 1, then negative 1. So what is our coefficient?
Negative x plus 2.
Negative 1 to the n. Good, Luke. It's just the alternator coefficient. Also, this variable expression looks a little bit different because what powers are we missing? The odd ones. So what variable expression could we write to just get even powers? There's a 2 involved, but where does it go?
Plus, to the
Exponent. So it's x to the 2n.
x.
So that means, let's just try. If we plug in 0, what's my coefficient? 1. What's my variable expression? X to the 0 is 1. So that's where we get our first term. If I plug in 1, what's my coefficient? Negative 1. What's my variable expression? X squared. That's where I get negative x squared. If I plug in 3, no, sorry, is that what I'm plugging in? If I plug in 2, what's my coefficient? What's my variable expression?
X
X to the 4. So that's where I get this next one. So it is a power series. It's just written out for you. What's power series?
Coefficient times x to the power.
Coefficient times x to the power. Is there a test? What? Test. So what were those tests from last unit to tell us something what? Converges or diverges. And so we're going to try to figure out when these converge and when these diverge, what x values to make them converge and diverge. And so that's what we're going to do after lunch.
Okay.
Bye.
And we're back. Did everyone have a good lunch?
Yes.
Oh, good. So now's when we're going to take notes. But to summarize what you may have forgotten during lunch, if someone comes up to you on the street and asks you what a power series is, what do you say?
Coefficient times x to the power.
Yes, say that and then ask who you are. But answer their question first, Ike. Today, we're going to talk about power series, which are coefficients times x to the power, and their interval and radius of convergence. So our goal, you can write it down if you want to, is to use the ratio test to determine power series convergence. I love the ratio test. We will use the ratio test all the time.
So is the best?
This is the most used test. So our goal for today is that we're going to use the ratio test to determine power series convergence, which means we probably need to remember what the ratio test is. Ratio test says you take the ratio of your next term and your current term and look at the limit as n goes to infinity. It has got to be less than 1 in order to converge. What happens if that limit of the ratio of your consecutive terms is greater than 1? Diverges. What happens if it equals 1? Inconclusive. So we're going to get back to all of 3 of those today. There are 3 possible outcomes as we test for convergence. The first possible outcome is that our power series could converge for some interval. And that interval is defined as the absolute value of x minus a is less than r, where a is the center of the interval and r is the radius of convergence. So you can converge for some interval. That's your first outcome. The second outcome is that you could converge only at one point, and that's going to be at your center. And the third possible outcome is that your power series could converge for all real numbers. So we're going to look at case 1. First game, next round of this game, is this a power series?
Yes.
What's your coefficient?
1 over n.
1 over n. What's your variable expression?
X minus 3.
X minus 3 to the n. Where is this power series centered? At 3. Good. So this is a power series centered at 3. What I want to know is what x values can I plug in for x and get out an answer. So for what x values, if I plug them in, will that series converge? For example, just looking at it, if I try to find f of 100, if I plug in 100 to that series, do you see that's 100 minus 3, which is 97 to the n over n. Is 97 to the n over n going to converge or diverge? It's going to diverge. If you do the divergence test, your terms are going to infinity. They're getting really, really big. Does that make sense? So 97, x equals 97, sorry, x equals 100. Definitely not in my interval of convergence. If I plug in 100, it diverges. But what happens if I plug in 2? What do I get on top?
Wouldn't it just be
Negative 1 to the n over n. Does that converge or diverge? That converges by the alternating series test. Does that make sense? So in my interval of convergence, what I'm trying to find is what x values make this converge. That's the point of today. What x values make this converge? We determined 100 does not work, but 2 does work. And so my goal is to figure out all the values that make it converge. Does that make sense? 2 is one of them. I want to figure out the other ones. The way we're going to do that is with the ratio test. So we're going to perform the ratio test. We're going to look at the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. So I'm going to look at a sub n plus 1. And I do want to divide that by a sub n, but that's going to look really messy. So what am I going to do instead? Good, multiply by the reciprocal. So times n over x minus 3 to the n. I'm trying to figure out where, for what values of x, this power series converges. Usually when we do ratio tests on non-power series, we just evaluate that and see if it's less than 1 or bigger than 1. But now we don't know what x is. We're trying to solve for x. And we want this to converge, which means that this has to be what?
Less than 1.
We're going to set it less than 1 and solve for x. Does that make sense? We're saying this has to be less than 1. Let's solve for the x's that make that true. Which looks really complicated. This is an inequality. You're supposed to isolate x. X is all mixed in there. But with ratio tests, the power of it is that it simplifies really well. So our next step is going to be to simplify our ratio. What I usually do when I simplify the ratio is I bring to the front everything that will not simplify. What pieces in there are not going to simplify, not going to divide out? N over n plus 1. Those do not cancel. So I'm going to go ahead and write them out front so that I'm not tempted to cancel them. And then I'm going to be left, the x minus 3 to the n plus 1 and the x minus 3, they do simplify. Where do I have an extra x minus 3? One extra on top. So it's times x minus 3. And that has to be less than 1. So now we only have one x in there. That's great. It's looking a lot more simple. Now that I have it simplified, I want to take that limit. It's the limit as what goes to infinity? N. So I'm only looking at my n's. As my n's go to infinity, what happens to n over n plus 1? It becomes 1. So it's really just 1 times x minus 3.
It's limit n goes to infinity of x minus 3 less than 1.
But it's not the limit anymore. I just took the limit.
Oh, so
Does that
it's
make sense?
x minus 3 less than 1.
So just the absolute value of x minus 3 is less than 1. That x can be any number you want, so it could be positive or negative. That's why we have to keep the absolute values on.
So then you solve?
Yeah, so then I want to get x by itself. What do I have on the outside of my x's right now? Absolute values. So going back to like math 2 or math 1, when you first learn about absolute value, it's exactly good then. I'm going to explain that further. If the absolute value of x is less than 1, what can x be between? Negative 1 and 1. So to drop absolute values on inequalities, you put your inner function between negative 1 and 1. Does that make sense? If I wanted to figure out what x's are less than 2, well, x has to be between negative 2 and 2. So you can drop absolute values out of inequality by putting between the positive and the negative.
So do you bring the 3 over?
Not yet. First, I just want to drop my absolute value, which means I need to put whatever's inside between negative 1 and 1. Does that make sense? So I'm really close to getting x by itself. What do I do to get x by itself?
Plus 3 minus 3.
Not plus 3 minus 3. This is x minus 3. So what do I do to both sides? Add 3 to both sides. That means I add 3 over here and get 2. And I add 3 on the other side. Wait, is that right?
Yeah.
And I get 4. Sorry. So x is between 2 and 4. So this is my interval of convergence. I'm going to converge as long as x is between 2 and 4. What's the center of that interval?
3.
3. Where is my series centered?
3.
3. So that's always going to be true, that your center is actually going to be in the center of your interval of convergence. I am not done though, and this is what my students always forget to do, no matter how many times I tell them, don't forget to do this. What happens if I plug in 2? What do I get? 2 minus 3 is what? Negative 1, and it's 1. And if I plug in 4, I also get 1. What happens on the ratio test when you get equals 1? Inconclusive. We don't know at the endpoints where it equals 1 if it converges or diverges. Does that make sense? So when you get to this point, you're not done yet. You must check your endpoints because that's where the ratio test is inconclusive.
So is this like in math theory or pre-calc when you would check for extraneous answers?
No, it's a little different than that. What it's really saying is we found all the places where the ratio test has definitely converges, but we forgot about the inconclusive part. So it's the same idea of like once you get a solution, you have to check and make sure that you didn't cut anything out in your reasoning. So sure. When I say check endpoints, I literally plug in 2 to my power series and see if it converges or diverges. So I'm going to go back up to that power series, and I'm going to plug in 2 for x. So if I plug in 2 for x, I get the sum from 1 to infinity of 2 minus 3, which is what? Negative 1 to the n over n. Does that converge or diverge? Converges by what test? Alternating series. So you do have to remember that from last unit. Every alternating p series diverges. Or sorry, that's so wrong. Cut that from this recording. Every alternating p series does what? Converges. All the terms are going to 0, right? And that's all that we care about for alternating series. So every alternating p series, that's going to converge. So we know x equals 2, that's part of our interval. Now I need to check my other endpoint. Which means I plug, really I should write it to here. I plug 4 in to my power series. And I get 4 minus 3 to the n, which is what? 1 to the n, which is just what? 1. And that endpoint makes it diverge. Because it's harmonic. Good. Alternating harmonic converges, which is the left endpoint. Regular harmonic diverges. So what I can conclude is that my interval of convergence is when x is between 2 and 4, and which of my endpoints also work for convergence? 2. So that's my interval of convergence. Every number between 2 and 4, 2 is included, 4 is excluded. What's the radius of convergence? Where's it centered? 3. And then what's the radius? 1.
So,
Not really. That was direct comparison.
Well, I mean, like the interval.
Yeah, so knowing those harmonic of this P series, you'll use those all the time. So we just found a power series whose interval of convergence is 2 to 4, 2's included. So we know that that function is only defined between 2 and 4. What happens if I try to plug in 7? It's going to diverge. I'm not going to be able to get a number out. What happens if I try to plug in 3.7? I'm going to get some number. I don't know what that number is, but I know it's going to converge. Does that make sense? Cool. Case 2. First game is this power series. Yeah, what's your coefficient? N factorial, what's your variable expression? X to the n, where am I centered? 0. I'm centered at 0. Good. So we are going to try to figure out what value, for what values of x this converges. What test do I use every time? Ratio test. So I'm going to look at the limit as n goes to infinity of the absolute value of a sub n plus 1. So n plus 1 factorial times x to the n plus 1. Usually I multiply by the reciprocal instead of dividing. Can I have to do that here? No, I don't have a double number fraction, so I can literally just divide. I can factorial over x to the n. I'm trying to figure out when does this converge, which means this has to be what? Less than 1. I set it less than 1 and try to solve for x. What's my next step? Simplify. That's really messy, but ratio test does lots of canceling with factorials and exponents. Is there anything that cannot cancel?
No.
No. So I'm going to start with the factorials. What's n plus 1 factorial over n factorial? Just n plus 1. Yeah, in the numerator. So just n plus 1 in the numerator. What's x to the n plus 1 over x to the n?
X.
Just x in the numerator. And we need to figure out what values of x make that less than 1. What's my next step? Take a limit. Take a limit as n goes to infinity. X doesn't do anything. N is going to infinity. What's happening as n goes to infinity?
Not that.
What's it going to? Infinity. Do you see that this is just getting huge?
Yeah.
We're taking a huge number and multiplying it by x. And what do we really want that product to be? We want it to be less than 1. So Adrian just laughed. Why did you laugh, Adrian?
Can you do that? Like it's going to infinity.
Yeah, can you even do that if it's going to infinity? You can do it as long as x is one thing. As long as x equals 0. Does that make sense? This is blowing up. N plus 1 is getting huge. So the only way that it's going to be less than 1 is if x equals 0. So x equals 0 is the only value that makes the inequality true. So we just found a case where we only converge at one number, and that's at our center. We say this converges when x equals 0. Does it make sense to talk about an interval of convergence? No, we don't really have an interval. So sometimes you just write it in brackets. Like, there's only one number in that interval. It's just that. It's just 0. There's no interval. Does it make sense to talk about a radius? No, there's no interval. It's just a point. So you could say radius is 0, but that's, you don't really need to say that. Good with that?
Yeah.
Case 1, we got an interval. It can be between these numbers. We checked our endpoints. In case 2, we get it only converges at one point, because the rest of the time it's blowing up unless it's 0. Quick pause. What if this was x minus 2? Where would it converge?
2.
At 2. It has to converge at its center, because that's what's going to make it 0. Does that make sense? So it's not always x equals 0. It's whatever makes it 0. And last case. This one looks really crazy.
That does.
Oh, wow.
But ratio test takes crazy things and makes them less crazy. Maybe I need to ratio test James.
Hope he hears this.
He probably won't. He's probably not going to listen to this.
Yep.
Catherine will.
Yep.
You don't think Catherine will?
I think
I think
so.
You think it's the opposite?
Yeah, James really likes doing math.
He does. He watches a lot of math YouTube videos.
Does he like math more than you?
More than I like math?
Yeah, I think he does.
You know, I think he likes math more now than I did when I was his age.
You should always.
I like math and content.
I came to math at lunch. I could have skipped all my language arts and social studies classes and all my science classes except for like one, all throughout middle school, taking everything up through elementary school. Just done math in one science class I would have from high school.
No, you wouldn't have, because it's in math you learn concrete things that you're like, if I wasn't in class, I wouldn't have learned that.
No, I'm saying have math classes.
Right, but English, you're like, I don't learn anything in English, but you do. You just, it's not concrete. You have exposure to reading and writing. I will say that I am a much worse writer now than I was when I was in high school because I don't write as much anymore. And you learn by like exposure, by doing, which stinks because math is just fun. And English, you actually have to sit and read and write to get better.
It's boring.
It's not boring.
I don't read.
Oh, it's like, no.
Yes, I love reading. Okay, we're gonna do case 3.
Yes.
I'm trying to figure out what values of x can I plug in and make that converge.
Yes.
I have no idea what to do, so what do? Ratio test. I'm gonna look at the limit as n goes to infinity of the absolute value of -1 to the n plus 1. I have to be really careful here. What's the exponent on x when I plug in n plus 1?
Oh, what is it?
2n plus 2.
2n plus 2. It's 2 times n plus 1, which is 2n plus 2.
Over
Over 2 to the what power?
2n plus 2.
2n plus 2
N plus 1 factorial.
times n plus 1 factorial. And how many of them do I have?
Squared.
2 of them. It is a lot.
You put the exclamation point in the front, in like the inside the parentheses or else?
I want to do n plus 1, the factorial of n plus 1, and then I want to square it.
Okay.
So you have to like separate it out like that. And then next part is easy. I just want to multiply by the reciprocal, so I just rewrite everything as is. And I want that crazy ratio to approach something that's less than 1. And I want to solve for x. If I told you when you first learned how to solve for x that you were going to solve that for x, what would you say?
I dropped.
Last time,
But ratio test makes this not that bad. I want to start with the stuff that I cannot simplify. Is there anything I can't simplify? No, everything's exponents and factorials, which are really great to simplify. Next, do you see that I have -1 to the n plus 1 over -1 to the n?
Yeah.
What does that just equal?
Negative.
-1, which I don't really need to write. Why not? It's in the absolute value, so I'm just going to drop that part. Making it positive or negative doesn't change.
Oh.
So I'm going to drop the -1s. I usually like, I mean, we can go wherever we want next. Where do you want to go? The x's. Actually, you usually say the x's for last. It's not wrong. Let's do x's last. What do you want to do?
2.
The 2's. Where do I have extra 2's?
The bottom.
How many extra?
2.
2 extra. So what's that going to be on the bottom?
4 squared.
2 squared. So I'm going to make that 4.
This one.
Let's do factorials. Let's forget about the squareds right now. We just have 2 of them on the top and 2 of them on the bottom. So it's n factorial over n plus 1 factorial. Where do I have the bigger one? Bottom. And how many terms do I count down before they cancel?
1.
Just 1. So I'm just left with n plus 1. Does that make sense?
Yep.
And how many of them do I have?
1.
Well, I have 1, and then I do it again. So it's n plus 1 squared.
Squared.
if I had n factorial times n factorial over n plus 1 factorial times n plus 1 factorial, that's what that means. And then I get n plus 1, n plus 1. So it's n plus 1 squared. And last thing I need to simplify are my x's. Where do I have extra x's?
The top.
The top.
So
How many?
2.
And that needs to be less than 1. So look how much simpler we just made that. It was crazy, and now it looks really simple.
Let's be careful.
You do have to be careful.
It's
That's just a good life lesson, so be
It's
careful.
just for kids' minds are shoving this.
Yeah, it's true.
Safety.
But now you all aren't scared. What's my next step? Take the limit. As n goes to infinity. Nothing changes except n's going to infinity. What's happening to that fraction? It's going to 0. Does it matter what x is? No, this is getting huge in the denominator. No matter what x is, the bottom's going to infinity, which means that that is 0, which is less than 1. My bottom's getting big, it's going to 0. What values of x make that true? All of them. No matter what x is, that's going to be less than 1. Yeah, so this is true. Well, I'm going to give you good math notation. For all x. Have you seen that upside down a before?
No.
That means true for all x.
Is that green?
It is math.
That's nice.
Maybe it's Greek. I don't know. Don't ask me that.
It's definitely like some kind of.
Can I say something?
Yeah, it's just math. It's like therefore.
You would see that.
Someone posted on their Snapchat a picture at Mikado's and said the Greeks make great food. And I just found that's really dumb.
Why would that?
I don't.
Wait, what?
I don't know, it just like yeah, exactly.
Okay, focus. We're not done.
Great food.
So this is true for all x, which means what is my interval of convergence? Negative infinity to infinity. Do I need to check my endpoints?
Nope.
No, I don't have any endpoints. This goes on for forever.
Oh.
So what we just showed was that when you have a power series, which is just coefficients times x to a power, you're trying to figure out what x's make that converge. 3 options. You can either get an interval centered at a and some distance on either side. You can get that it only converges at one point, or you can get that it converges at all the points. Options are some finite interval, some at a single point, and all real numbers. We did one of each case. Are you usually going to know which case it is? No, that's why you do the problem, to figure out where it converges. Do what?
So we just did all the possible outcomes here.
Yes. We just hit all the possible outcomes.
Duh.
That's it.
We're going to do 2 more examples where we don't know the outcome, so we're going to figure it out as we do it. Let's do this example. X minus 2 to the n over n times 3 to the n. I want to figure out what's my interval and radius of convergence.
Ratio.
Yes. First of all, it's a power series.
Yes.
Where is it centered?
2.
2. So every single time we start with the ratio test. We're going to look at the limit as n goes to infinity of the absolute value of x minus 2 to the n plus 1 over n plus 1 times 3 to the n plus 1. I don't want to divide, so I'm going to multiply by the reciprocal, n 3 to the n over x minus 2 to the n, and I know it has to be less than 1. I'll pause.
Thank you.
So that was a lot. How did you
Practice.
I practiced last night for 5 hours on this problem to make sure I can say it that fast.
Yes.
I feel like you actually did.
I did.
Just said she did.
I do not believe me.
I mean, sometimes you always are kind of.
Like a
I'm never sarcastic.
last night.
Are we good with that? Now we need to solve for x. That looks crazy, so what do I do?
Simplify.
Simplify. I really like to start with the stuff that's not going to cancel. That's anything that's not an exponent or factorial.
3n plus 1.
N over n plus 1. That will not divide out. So I like to put that out front. And then the rest of the stuff I get to simplify.
Times,
Where do you want to start?
x minus 2.
X minus 2, sure.
Do you know
Where do I have an extra one? Yeah,
On top.
on top. How many?
1 x minus 2
I got an X minus 2 on top.
over
Over what?
3.
1, 3. So much simpler.
And
You
then,
can. That's why you keep it in parentheses. But I usually like to separate it out. Because I really like to keep my ends separate from my non-ends. Why would I like to keep that separate? Because I'm taking the limit just of the ends. Everything else just stays.
equals uno.
So that limit equals uno, which means that it multiplying by 1 does not change anything. So that's what I'm left with when I take the limit.
Which
It has to be less than 1. Now I'm just solving for x. What do I do to solve for x?
Do the
-1 to 1 to drop the absolute value.
wait, how do you know it's negative 1 to 1? Like you just look at your.
I look at this.
So it was 4.
It'd be -4.
Okay.
So -1, but it's always going to be -1. Why?
multiply.
Because ratio test is less than 1. So we're not going to have anything else over there. So I drop absolute values by putting what's inside.
And then
Is there a name for what's inside absolute values?
What?
You know, like under a radical is the radicand, inside an integral is the integrand.
Absolute value.
Absolute valicand.
Yeah.
Okay. So I take the absolute valicand and put it between -1 and 1.
And
So
then
you multiply by
three.
car.
Multiply by 3.
Negative 3. This is actually easy.
And then what do I do?
Add 2 on each side.
Add 2 on each side, and I got between -1
And
and
5.
5. Great, I found my interval of convergence.
And then you check the endpoints.
Check your endpoints, good Phil, I am not done. I find an interval and I'm super excited, but I'm not done. So I'm not going to box anything. I'm going to check my endpoints. How do I check endpoints?
You plug in -1 into your.
Yeah, I plug them into my original function. So if I plug in -1, I'm going to get -3 to the n over n times 3 to the n.
Over.
Does that converge or diverge?
You do alternate.
Yeah, it looks alternating, but I really want to simplify that first. What looks like it would cancel out? Yeah, but it doesn't because that one's -3, right? So we're going to talk about this in a second. I can separate out the -1 to the n and the 3 to the n. Does that make sense?
Yeah.
If they're both raised to the n power, then you can put them in parentheses and take them to the n power together. So you can also split them apart. -1 to the n and 3 to the n.
So then I do.
And then I have n over 3 to the n, and then I can cancel them.
That's cool.
Oh, okay, I see.
So is that divergent?
So this is -1 to the n over
it's
n,
convergent.
which is convergent, because the terms are going to 0 and it's alternating. So that endpoint works.
I see.
So then for the next one, we can cancel them out.
Good. And so the next one's easier,
3.
because when I plug in 5,
3 to
I just get 5 minus 2 to the n, which is 3 to the n, over n3 to the n,
cancel them out. 1 over n.
and I get 1 over n, which we know does what? Diverge. That's the harmonic series. So one of my endpoints works, the other one doesn't.
So it's -1 less than equal to x. Less than.
So my interval is definitely between 1 and 5, or sorry, -1 and 5. I'm going to write it, you can write it with inequalities. I'm going to write it in brackets. Do I include -1 or not?
Yes.
Yeah.
Yes, include -1. Go all the way to 5. Include 5.
No.
No. There's my interval convergence.
Is there interval of divergence?
Everything else.
Oh.
Where is this interval centered?
X equals 2.
At 2. Do you see that this power series is centered at 2? This interval is also centered at 2. And so what's my radius?
I'm so what ratio?
2.
2.
2.
If I'm centered at 2,
3.
Oh.
my radius is 3. I go 3 up from 2 and 3 down from 2.
Wait.
We're good with that one.
Is there a reason you make go to 1 instead of root to 0.
Does it say n equals 0? Oh.
Yeah, it does at the beginning.
No, there's no reason. It doesn't change whether your series converges or diverges. Because does the first term ever determine if your term series converges or diverges?
Nope.
No, it's just a finite term. So, I mean, I could write these terms to make it clear that that's what I'm using, but it does not affect convergence or divergence. So we just did something that I want to write down so that you remember that you can do this. This is so helpful for simplifying when checking endpoints. And that's the property that an times b to the n, a to the n times b to the n is a times b to the n. A to the n, so these are powers.
Somewhere.
A to the n times b to the n is the same thing as a times b all to the n.
That's what you did.
And I mean, you know that, right? When you have 3x to the third, what does that equal?
9x cubed, or no, 27x cubed.
That equals 27x cubed. It's the same thing as 3 to the third times x to the third. Like you've been doing that your whole life, but you probably haven't written it like
3x
this.
times 3x.
Does that make sense? So, ways that that's really helpful. For example 1, if I do 2, if in my series I have 2 to the n times negative 1/2 to the n, how can I simplify that? That's the same thing as negative 1 to the n. Because you can multiply your insides and raise it all to the n power. If I have, we just did this one, negative 3 to the n, how can I split it up? Yeah, I can take the alternating piece off. You negative 1 to the n times 3 to the n. That's also going to be really helpful. But to put them together and split them apart, depending on what you want to be able to cancel out. Last example, if I have negative 1 to the n, 4 to the n, and negative 1/4 to the n. That equals 1 to the n. You can multiply everything together. And what does 1 to the n equal? 1. So that property is going to be really helpful as you're simplifying when you're checking your endpoints. Ready for your last example?
Yep.
Cool. Me too. I'm excited. Nope. Why are you scared?
The root series.
No, it's not. Just a p-series-ish thing.
All right.
Okay, so I want to know, for what values of x does this series converge or diverge? Is it a power series?
No.
Yeah.
Yeah. So it's centered where? Negative 3. My options are that it converges some interval centered around negative 3. It converges just at negative 3, or it converges for all real numbers, right? That's what I'm trying to figure out. Which of those 3 is true? How do I figure it out, Phil?
Huh?
What do I do?
Oh, ratio test.
Ratio test.
Sorry, I'll blink out for like a good 5 seconds.
Limit as n goes to infinity. Where does that x plus 3 to the n really belong? The top. So, absolute value, I mean, it's negative 2 to the n.
It's 2 to 0.
Yeah, do I need that negative?
No, 'cause
It's
I think
inside
that-
my absolute values. I do not need it. Does that make sense?
So
So I'm just going to drop it. It's 2 to the n. I need the 2,
yeah.
but I don't need the negative.
Plus 1.
2 to the n plus 1, thank you, times x plus 3 to the n plus 1 over the square root of n plus 1. Multiplied by the reciprocal, root n. I'm going to drop the negative. 2 to the n, x plus 3 to the n. And I need that to be less than 1 in order for it to
Why
converge.
is less than 1? Okay, we simplify.
Good, then I simplify.
You can't simplify the roots.
Good. So I'm gonna pull them out front because I can simplify these. The rest I can simplify. What am I left with?
2
Where is the 2?
on top.
On top, and what?
X plus 3 on the top.
And an x plus 3 on the top.
Right.
Now I've simplified. Next step, take the limit, and what does the limit equal? 1, same leading coefficient. Or same degree and ratio of leading coefficient. So that's just going to all go to 1, and I'm just going to be left with that. What do I do to get x by itself? Drop the absolute values by putting it between -1 and 1. What do I do next? Divide by 2. And subtract 3. So what is -1/2 minus 3? -7/2. And 1/2 minus 3. -5/2. So this definitely converges over some interval. It's case 1. Case 1 is the most common. Am I done? What I have to check? The endpoint, because that's where the ratio test is inconclusive. So I'm going to plug in -7/2 to my series.
So it's 7 to the end.
So it's -1/2 to the end. -7/2 plus 3.
Oh.
Does that make sense? Add 3, you get -1/2. So I get -2 to the end times -1/2 to the end over root n.
So bad.
What? I didn't think it.
I heard it.
Is it 1 to infinity? Oh, it's 0 to infinity, which is really bad. It should be a 1. Why should it be a 1?
It's
It's undefined as 0. Sorry, my bad. N equals 1. I don't know what that does until I simplify it. But using what we just talked about, that simplifies into what? 1 to the n, which is just 1. So converge, diverge, diverge by P series.
Yes.
And the other side, plug in -5/2. What's -5/2 plus 3?
Yeah.
Positive 1/2.
Yeah.
So I get -2. Do you see that this negative is important? That's not an absolute value when you plug it back in. So that's when you got to bring the negative back. 1/2 to the n over the square root of n. And then we simplify. What does that become? Which we know does what? Convergence. This is conditional convergence. That alternator makes it converge.
Oh.
Nice.
So my interval of convergence is -7/2 to -5/2. And what's one of the endpoints works? -5/2.
And then the raise is 1/2.
Good. Where are you centered?
3. -3.
-3, and you go up a half and down a half from -3. That's your piece. Are these not sort of fun?
Yeah.
It's fun, but
It's work intensive. Like you, look how much work one problem is. But it's each step is not that hard. I really like this. I think it's fun. We did 3 examples of case 1. What did we not do any more examples of? 2 and 3. So let's look back at those because you do have those on your homework. You're going to, if your limit is going to infinity, do you see how this limit goes to infinity? If your limit goes to some number, you're going to get an interval. If your limit goes to infinity, it's only going to converge at one point. What point is that going to be?
Whatever x equals.
The center.
7.
The center. So whatever makes x minus a 0. And case 3, if your limit's already going to 0, then it's going to converge for all real numbers. But if your limit's going to some number other than 0 or infinity, that's when you're going to get an interval out. Got to check your endpoints. Anyone have any words to say for Catherine and James, or Nellie if she watches this, or Tamira who wasn't here today?
Thank you.
Thank you. Why are we thanking them?
That's all.
Hope you enjoy it, James.
Math was
Like,
Philip.
subscribe.
Like and subscribe. Or come to class. That's also a really good idea. Come to class.
Left blood.